To draw Lewis dot diagrams. We're going to go up into a simple method of how to draw Lewis dot structures for anything you want to. It requires you to follow a specific sequence of steps, and we're going to walk you through those steps so you can better understand this. First thing you want to do is add the valence electrons for an element or a compound. So let's say, for example, we have NO3, we'll go NO2. So if you look in the periodic table, nitrogen is in group 5A. That means it has 5 valence electrons. Whatever group the element is in, we're going to skip the transition metals, so ignore those. Only focus on the A. So 1A, 2A, 3, 4, 5, 6, 7, 8. Those are the groups you're going to be worried about because those dot structures are really exclusively for non-metal substances, which makes molecular compounds. You could theoretically do it for ionic compounds, but we're not going to deal with that. So you have 5 because nitrogen is in group 5A. Oxygen, if you look at it, is in group 6A. So that means a total of 6. And you multiply times the subscript. So that's going to be 12. So theoretically, this would have a total of 17 electrons. That's how we figure out the number of electrons a particular element has using that system. So once again, just count the number of electrons based on its group number. And if there's a subscript, multiply by that. And just give you one more example of it. Let's say we have CCl4. Carbon has 4, because it's group 4A right here. And then Cl has 7, because it's group 7A. And 7 times 4 is 28. So here we would have 32 electrons. You're going to place the lowest quantity element in the middle and connect to the rest of the elements in the compound. It just ends up working. One of those unique situations where simplicity is best. So in this situation, it would be carbon. In this case, it would be nitrogen. Whatever you have less of technically is your middle. What if you have 2 of the same thing? Then you pick whichever one you want as the middle, because they're both the same thing. I do want to point out, though, if carbon's involved, carbon has to be the middle. Carbon is always the middle, can't be the outside elements. 3, use the valence electrons to give the elements on the outside 8 and put any leftovers on the middle atom. So let's say we're doing CCl4. So we put C in the middle. We're going to connect it to each chlorine. And this is where the game begins. You have a total of 32 electrons. Used up 2, 4, 6, 8 to connect. Now, 2 dots, the same thing as a line. So whether you want to do dots or lines, really up to you. I think lines are a little bit easier. But if you are bent on dots, then do dots. Just remember, each line is equal to 2 dots. So if I do this, I'm implying 4 dots. If I do this, I'm implying 6 dots or 6 electrons. That's the maximum you can go, is 6 to have a triple bond. 2 would be a double bond. All right, so you place the lowest quantity in the middle and use valence electrons to give the outside elements an octet. Octet meaning 8. So remember, I used 2, 4, 6, 8 already. So I started with 32, used 8, so I have 24 left. So watch how I keep track of the rest. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I used up all my electrons, all 32. And that's the most important thing you want to do. Put all your electrons down to make sure you can see what's going on. Don't anticipate. Don't try to hypothesize a double or triple bond. Just put them all down. You can always erase and move afterwards. So in this situation, we go to step 4 now. Since your atom doesn't have 8, it does. 2, 4, 6, 8. I'll do a double or triple bond, which I don't need to in this situation. So in this situation, this is the complete Lewis dot diagram for it, showing that carbon has a total of 8. Remember, the way this works, this has 8 because there's 8 electrons around it. Each chlorine also has 8, 2, 4, 6, 8. Same reason, because it has that many electrons around it. So this double bond, that accounts for both of the substances. It accounts for both the carbon having 2 here and also the chlorine having 2. So now everything has 8. You're done. You can move on to the next structure. So let's try some more examples of this to see how well we understand it. So we're going to go to CCl4. And I'll put the periodic table up initially so you can see what it looks like. So in the case of carbon, 4, because group 4A. Iodine, group 7A, but there are 4 of them, so it's 28. So 32 electrons. So I'm going to put C in the middle, because I have less of it. Put I's around it. 1, 2, 3, 4. Now I need to make sure everything has 8. I have a total of 24 more electrons, so I'm going to put all of them down. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. There's all 32 electrons. Everything has 8 that wants 8, so I'm done. That's the correct Lewis dot structure for Ci4. For ammonia, that's a group 5A, so 5 electrons. Hydrogen's group 1A times 3 gives me 3 electrons, so it's a total of 8. Now, hydrogen doesn't want to have more than a total of 2 electrons. Once you connect to hydrogen, you're pretty much done with it. So in this situation, I'll put N in the middle. So 2, 4, 6. There's all 6 of my electrons. Now, what do I need to do in this situation is that I have 2 left over. So what do I do with it? Well, whenever you have leftovers, you just stick it off the middle. Do not try to do a double bond or anything cute like that. Just stick it off the middle, and usually it works out. Elements from period 3 and beyond can have more than 8. So sometimes you'll get more than 8 around the middle. It's possible. And we'll get some examples of that in a second. So in this situation, there's the correct Lewis dot structure. Notice 2, 4, 6, 8. Nitrogen has 8. Hydrogen only wants 2. So once you connected hydrogen, you're done with it. Don't ever do a double bond. Don't ever do a triple bond. You'll be messing up. All right, sulfur is in group 6A. So 6. Oxygen's also in group 6A, right there. It's 18, 12, 24 electrons. That's in the middle. O, O, O. These are connections. There's a total of 6 electrons. So I have 18 left. 2, 4, 6, 8, 10, 12, 14, 16, 18. All my electrons are down. Here's the problem. Once I do that, I look at the middle. The middle for the first time doesn't have 8. So what do I do? When you're in that situation, all you need to do is go in there, erase a pair from whatever element has more electrons. In this case, it's going to be the oxygen, and just double bond. So now this oxygen has 8. This sulfur has 4, 6, 8. Everything has 8 that wants 8. You still have 8, so that's fine. Now you'll notice in this situation, I could have done the double bond here, here, or here. When you have a choice like that, it's called a resonance structure, which is a fancy way of saying you have a choice where the double bond goes. So whenever you have that situation, you're supposed to draw 3 variations. So in this situation, you're supposed to draw, the way you do it, you draw a double arrow, then you draw the other variation of it. So my other variation is going to be, the double bond is going to be on the top O instead of the left O, and then one more. In this situation, I should have drawn on the bottom, so just visualize this to be at the bottom, but the middle O, let's call it that. And on this one, I'm going to put on the right O. So watch, sulfur, put the double bond there. I'll be consistent this time. O, and then O. That's the correct Lewis dot structure for it. So this is all 3 variations, and whenever you have a resonance structure, you want to try to draw all 3 variations. Let's move on down. So iodine is group 7A, so 7 electrons. Fluorine is also group 7A, also 7 valence electrons, but 7 times 5, just 35, 42. I in the middle, 1, 2, 3, 4. Now where do I put the 5th? Common mistake is just put off another fluorine. Don't do that. Elements from period 3 and beyond can actually hold more than 8. And the only time you really have a situation where you get multiple middles is when there's multiple carbons. And I'll show you an example of that later. So 2, 4, 6, 8, 10 electrons. So I have how many more? 32 left, right? 42 minus 10 is 32. So watch what I do. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. I have 2 electrons left over. What do I do with it? Whenever you have extra, stick it off the middle. Now, does it matter where, which angle, if you use this one or this one? No, of course not. As long as you have 5 bonded fluorines and 1 lone pair, you have the correct structure and you're good to go. All right, let's go to the next one. Now we're dealing with ions. So what do you do with an ion situation? So 5 goes nitrogen's group 5A, hydrogen's group 1. There's 4 of them, so plus 4. Now the charge, when it's positive, you subtract that many from your total. When it's negative, you add that many. So here it's positive, subtract 1. So 5 plus 4 minus 1 gives me 8. Put nitrogen in the middle. 1, 2, 3. And then I have 2 left over, right? So what do? Well, you have 1 more hydrogen. So that's where you put the last one. So I made the mistake and I put that first H. So 4 H's, 4 connections. All the hydrogens are happy. Nitrogen he has 8 as well. The only thing you need to do when it's an ion also is to put the brackets around the whole thing and put the charge to indicate what the charge is for that compound. All right, here's an easy one. We have 1 plus 7. It's a total of 8. So H, connect to Cl. There's 2, 4, 6, 8. You're done. Pretty easy structure. All right, next one, CO. We have a total of 4 plus 6, that's 10 electrons. So C, connect to O. There's 2. Carbon's my middle, so I'm going to go outside in. So the O is my outside element in this situation. So 2, 4, 6, 8, 10. Now you'll notice the oxygen has 8, right? 2, 4, 6, 8, but the carbon does not. So what do you need to do? Go in there, erase from whatever has more electrons. In this situation, that's the oxygen. So now 2, 4, 8, 4, 6. Still short, so what we need to do, once again, erase and move from whatever has more electrons. So I'm going to move it from the oxygen again, and we put it right there, and there we go. There's a correct structure for CO. There's a triple bond, 6 electrons shared, 1 lone pair for each, the carbon and the oxygen. All right, Cn minus, 4 plus 5, negative, so we add that many, 1. Now we have 10 electrons. C in the middle, connect to nitrogen. So 2, 4, 6, 8, 10. Now I know there's going to be a double or triple bond, right? But I'm not going to anticipate. I'm going to do things in the same order so I don't have to make a mistake. So erase and move, put it in between. And then you notice once again, still short. So we're going to erase and move. Now you have the correct structure. The only thing I forgot is the brackets and the charge to indicate what it is. All right, SO2, 6 plus 12, 18. That's in the middle. Connect to the O. Connect to the other O. 2, 4, 6, 8, 10, 12, 14, 16, 18. Remember, whatever you have left over goes on the middle. So we see that the sulfur doesn't have 8. So erase and then move. So I'm going to put it right there. And you have the correct structure. Now, this is your resonance structure again, because you see you have the double bond here, but could have also been here. So either one would have been fine. You should have drawn both, but I'm not going to for this one. All right, chlorine, 7 times 2 is 14. Cl, there's 2, 4, 6, 8, 10, 12, 14. I'm done. That's all you have to do. Everything has 8. The one's 8. Have a nice day. All right, boron. Boron has 3. Chlorine has 7 times 3, which is 21. 24 electrons. Be in the middle. Connect. 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 That's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I put all my electrons down, and you may say to yourself, okay, well, that means the middle is short because it only has 6, right? Boron's unique. Boron only wants 6. So once you do this for boron, call it a day, move on. You don't put more than 6 around boron. That's one of the other exceptions. All right, SCN, we have a total of 6 plus 4 plus 5 plus the negative charge, so that's one more. So 10, 15, 16 electrons. C in the middle, and on one side, that's on the other. So that's 2, 4, 6, 8, 10, 12, 14, 16. You notice I go outside in. The inside is my last concern. Now I look at the inside, you're like, oh, wait a second, it only has 4. It's short. So what do? That's right. Erase from whatever has more electrons and move. So now you look at it and say, okay, well, this sulfur has 8. Carbon only has 6, though. It's still short, right? So what do I need to do? Erase and move. So what do you erase from? Whatever has more electrons. Sulfur does not have more electrons than nitrogen, so nitrogen is the winner. That's where we're going to erase from. And erase and move. Brackets, charge. We have the correct structure. I'm going to give you one more. An example of one that has a let's go carbon-based substance. Let's go with C2H6. So carbons can have multiple metals. So when you have carbons, connect them together. They're always going to be connected together. However many carbons you have, just put them in a chain. Then you put your hydrogens. Now, you want to equally distribute the hydrogens. What do I mean by that? So 2. They each have 3 hydrogens because it's 12, 6. So watch. And Forgot to count at the beginning, so that's 8. 4 times 2, right? Plus 6, 14. So look at my count, 2, 4, 6, 8, 10, 12, 14. Correct structure. Now, what if you had C2H4? Same thing, connect the carbons together. Mirror images, remember, equally distribute the hydrogen, so I'm going to give each one 2. That's always the case. So a total of 8 plus 4, that's 12. So 2, 4, 6, 8, 10, 12. Now, this carbon has 8, right? But you know, this one only has 6, 2, 4, 6. So what do I need to do? That's right, you guessed it. Erase from whatever has more in between. There's your structure. So the important thing to notice when you have multiple carbons, one, put them in, connect them first together, and then equally distribute the other elements so that each side has the same number. So that's how you draw those dot structures. Hopefully this will help you better handle them going forward.